In this session, we're going to talk about multidimensional arrays. You remember that we have four main types of aggregate data: arrays, strings, structures, and unions. And we remember that with an array, all of the data that's stored in the array is the same type. So they're all integers, or they're all floating point numbers, or they're all strings. What we're going to talk about now are arrays that hold multiple sets of data. So with our one-dimensional arrays, we were able to hold multiple samples. Now what we're going to do is add the ability to add multiple sets. So say, for example, before we were capturing 10 samples, maybe 10 temperature samples. Now we can take 10 samples every day for a whole month. So maybe we have 30 sets of 10 samples, and then we can use that information to gather data about a particular setting. So let's look at the declaration. Pretty similar to what we did for one-dimensional arrays. So we still need the data type. That might be integers or floats or characters or strings, any kind of data that we can hold. The name of the array, the number of elements is the same, and then what's new is adding the number of sets that we're going to take. So this would define our 10 temperature readings. This would define the 30 days that we're going to take those 10 readings. So let's look at some examples down here. We have integers that are going to be stored in an array called samples. We're going to take the maximum number of elements and number of sets. So if max number was our 10, number of sets was our 30, we would be able to take 30 times 10, or 300 integer values. If we look at another one here, our data for this one is float. The name of our array is readings, and we have sets and we have size. So this tells us how many elements. This tells us how many sets of elements we're going to have. Once we've declared our array, we can now start to store data in it. And the format to assign a value to an element in an array is just like assigning any other variable. We need the name of the variable. In this case, we have to tell it which set and which element, and then we assign a value. So there's our assignment operator. So let's take a look at the examples. There's our samples array. Remember, this held integers. We're going to go in the ith set, the nth element, and once this instruction is completed, we'll store the value that's stored in the variable called value. If we look at our other array, this was our floating point array called readings. We're going to go in the s set, the ith element, and we're actually going to call a function here that's going to get a number and assign it to this element in the array. Just like any other variable, we can compare or test an element that's in an array. So there's our array name, there's the index into our set, the index into the element, and here we're looking to see if value is equal to the element stored in the array. So we can use less than or greater than here. We could use greater than or equal, any of the comparison operators. So let's take a look at our examples here. So we have the sth set, the ith element, and we're looking to see if it's equal to the element that follows it. So we're in the same set, but we're in the I plus 1th element, which means we're looking at the next one. And in this case, we're maybe looking to see if we're holding a temperature. So we're saying the system is stable. If we look at our floating point array, we're looking at element J in set S, and here we're looking for greater than or equal to a limit. Now it's pretty important when you're looking at floating point numbers, remember, to never check for equality. Because of the way they're stored, we can never ensure that two floating point values are always the same. So make sure you're always using greater than or equal to or less than or equal to for floating point numbers. We can have the user enter values and store them directly in array elements. So we're going to use our standard input function scanf. We provide the format specifier telling what kind of value we're going to enter. We need the address of operator to point to our address, and then we specify which element in the array. So again, we need to remember to specify which set and which element. So if we look at our examples, if we're reading in our integer value into our samples array, there's our ampersand saying the address, and we're going to store this in the th set and the ith element. If we look at our floating point array, we have a floating point specifier, and again we're going into set s, this time into element j. So when we're working with a multi-dimensional array and we want to put a value in an element, we always have to specify an index for each dimension. There are many times that we want to access every element that's in an array. Say for example, we want to print them out, or we want to have the user enter values for each of those. Sometimes it's even doing calculations like trying to find the largest value or the smallest value or the average value. In that case, what we're always going to do is use a nested loop. So our outside loop is always going to control our sets, and our inside loop is going to control our elements. So in this case, we're looping from s equals 0 right through the total number of sets, incrementing our set each time. So we're going to go through set 0 first, and then inside set 0 we're going to start with element 0 right up to the maximum number of elements, increasing by 1 each time. And so that means we're going to go through every element in set 0, then we're going to go through every element in set 1, and so on. So let's take a look at an example down here where we're going to print the values out. So our outer loop starts with our sets, so we're starting with set 0. We're going up to but not including the total number of sets. So if I have 5 sets, I'm going to go set 0 through 4. Then for my index, in my actual elements, I'm going to start with element number 0 and go to 1 less than the total number. So if I have 10 elements, I'm going to go from 0 to 9, increasing 1 each time. So we're going to go through all the sets, or all the elements in set 1, followed by all the elements in set 2, and so on. So my print itself, I have integers in my array, so I need an integer indicator here. There's the name of my array, my index into my elements, and my index into my set. So I'm going to go element 0, 0 up to element maybe element 7 for set 0. Then I'm going to do set 1, 0 through 7. Then I'm going to do set 2, 0 through 7, and so on until I've done all the elements in the whole array. We also have to be able to pass our arrays into and out of functions. So sometimes we just want to pass one element from an array, and this is pretty straightforward. This is like passing one value in. So we have the name of our function, and then what we have to do in the call is specify the actual element by specifying its set and its index number. So let's say, for example, we have a function called useValue, and I want to pass in set s element I. There's the name of my array and my 2 indices, and now it's going to have access to the value that's stored in that element of the array. The function itself would look like this. Because my array samples has integers, the function is going to expect to get one integer value, and I'm going to call it value, and then I'm going to print value is, I have %d because it's an integer, and then I'm going to print out the element that I passed in. The last page, we looked at passing one value in. Well, sometimes we need to pass a value back, and we want to assign that to an array element. So in our function, it would have to have a return type that would match the element of the array, and then the name of the function. It may or may not have any input values. So say, for example, we wanted a function called getValue. What it was going to do was get an integer value and assign it to our array. So you can see we have the name of our array, we have the set indicator, and we have the index indicator into the elements. The function itself has to specify a return type that matches what's being held in our array. We do the prompt and the scan to get the value. We return it, and as long as this data type matches the sample's array data type, it will now, because of our operator here, be assigned to element Si. It's actually more common to pass in a set of data instead of an individual value from an array. So in this case, whatever the function happens to be, we need to specify the name of the array and the set that we're going to pass in. So say, for example, we have a function called changeArray, and what we want to do is work with one set of data from our array. Our array held integer values, so we need to specify the data type. Then we give the array a name for using inside our function, and we specify that it's going to be an array by including the empty square brackets. Inside our loop now, we can go through and we can say for I equals 0 up to the maximum number of elements, increasing 1 each time, we can read in a value for the array. So we're going element I, this is the address of, and what it's actually doing here is storing the value the user enters right into the array set that we passed in. So this would be a way that we could have the user enter one set of data at a time. There are times that we want to pass an entire array into a function. So this would be our whole multidimensional array. So here what we need to do, whatever the function is called, we need to specify that the whole array is going to go in. So if we look at the function first, there's our function. It's not going to return anything, so it's called changeArray. It's expecting an integer array with 2 dimensions, so we have 2 sets of brackets. Now it's very important to remember every dimension except the first one has to be defined. So we would use the constants that we had defined right up front to declare our array to say this is a 2-dimensional array. It doesn't matter how big the first dimension is, but I know the second dimension has to be set to maximum number. That allows the function to figure out by itself what the dimensions of the array are. Here we're going to have the user inputting values again for the whole array this time, so we need our nested loop, looping on the outside in our sets, the inside in our elements, and we're going to read into the address specified by element number Si. So it's going to loop through every element in the first set, then every element in the second set, and so on.